The next talk will be delivered by two people, Dr. Soham Ghosh and Kyle Schaefer from Xscale Solutions. They'll be talking about the various products that Xscale Solutions has for accelerating high-performance computing and AI applications. So let's welcome the speakers.
Put it higher. Put it higher. Better?
Yep, that's good.
Okay. Well, thank you all for coming. I appreciate it. It's late. So, I really waited for your attention. So I'll set the mic on. No. Okay. All right. I can just be here. Okay. So I represent Xscale Solutions, which is DK's own company. So I'm guessing and this is a talk about the product overview of Xscale Solutions. So I'm guessing I'm going to preach to the choir a bit on some of these products. It's a talk given by me and Kyle Schaefer, who unfortunately couldn't be here. And some of the work that I will show was also done by Bimersh, who is sitting here. So if you have some questions on those parts, I'll direct you to him. Okay, so let's start with an overview of Xscale Solutions. So this grew out of DK's No Lab, collecting all the expertise that the lab generated over the decades. So eventually, it sort of emerged that the research and the development that was going on in the lab could coalesce into something like a business model which has a commercial support, and then we could add value with that expertise to new products and package them as products. So the model then is applicable to essentially everything that the communication layer is applicable to. Which means, and plus the expertise of the group generated over the years. So then it becomes an end-to-end solution of services, support, and training, and then it applies to HPC and AI and also big data. So the support includes MVAPIC library, which is the core product, and the derivatives that come out of MVAPIC, like MVAPIC Plus. And then the applications go into deep learning and ML and HPC applications that use MVAPIC underneath. And then the rest of it is training and support. Okay, so we have a lineup of products which are the following. So we have one that's Xscale HPC for optimized HPC applications. We have something that's a little more recent, Xscale AI, which is specifically for training and inference. Then there we have an MVAPIC 2 application tailor-made for NVIDIA's BlueField DPUs. We have in particular Xscale PETC, which is a derivative or overlapping with Xscale HPC, because we took PETC as a representative candidate for an HPC application, because it powers so many different HPC applications. Then we have a very specialized product, Xscale Secured MPI, which probably will have some relation with the previous talk. And lastly, we have a lightweight Xscale monitor, which we use for HPC and AI monitoring. Okay, so me go over each of these products. So Xscale HPC we conceive it as a combination of two. One is the MVAPIC libraries and the optimization and the learning that comes with it, coupled with commercial support, where we do platform-specific optimizations and tunings. And then get feedback from users and go back to them and work with them for efficient deployment of MVAPIC-based HPC solutions on different platforms. So the value proposition that comes out of it is that mostly HPC applications are user-level software. So anybody can, usually you don't need an admin to do it. So you can individually collaborate with Xscale solutions to deploy them. It has the same advantages that MVAPIC inherently has, which means it is neutral to vendors, and it has excellent performance portability across various platforms, leading to the usual end benefits, which is a reduction of time to solution and reduction in your total TCO. And now power usage, which is increasingly more important. So we conceived Xscale HPC as an umbrella product, which as our core MVAPIC plus our expertise in optimizing applications using MVAPIC. Now, Xscale AI, on the other hand, takes MVAPIC, the optimizations that come with that, and applies it to the AI applications. Now, which makes it a bit unique, because we do pre-training, inference, fine-tuning, and hyperparameter tuning, but in a vendor-neutral way. So it has the same MPI-driven approach underneath, because we leverage MVAPIC. So most of the research of this comes out of the Ideal project, which Navras talked about yesterday. So we bake in the optimization that comes out of it. And then we can scale it. We can deploy it on cloud, and we can deploy it on premise, both as a container and as bare metal. We now support several models that are defined in PyTorch or Hugging Face. We have large language models. We have used Llama 3. I'll show you some results, and BART and some other encoder and decoders. We also have results on. We also can incorporate vision models. We have a scalable model checkpoint and restart support. This is particularly important if your model has a very long training time, and so instead of provisioning and nodes for hours or days or weeks, you can do all node checkpointing and then restart again, breaking up your jobs and freeing up resources for other users. One of the best thing about it is that we try to give you the best out-of-box optimal performance, which means you reduce your time in optimizing it once you deploy the application yourself, which is what many of us spend a lot of our time in. And it works on virtually all systems. It works on CPUs, x86 and ARM. It works on GPUs, and it's mostly interconnect agnostic, even though the results may vary a little bit. Okay, so it's envisioned as a product and a service. It has got baked-in service for both public and private models and data. We have recipes at our website that will get you started, and onboarding as well. And we incorporate pre-training, fine-tuning, and hyperparameter optimization for training and inference. We use both MPI and CCL as backend. And we have developed a custom API that sets up an optimized environment and will rapidly run training and inference if you don't want to spend any time doing it. It's basically click and deploy. It's as easy as one SRun submission. And then we bake in the support and expertise as part of it. Okay, so let me insist on the value propositions that come with it. One is that you have reduction in distributed training and inference time, and this reduction is used uniformly across all systems that you can think of, across CPU-based systems, GPU-based systems, across multiple interconnects. It's completely vendor neutral, the entire stack, and is as performance portable as it can be. Therefore, you can take the same solution, and with very minimal effort move it. In some cases, when it's containerized with almost no effort, move it from one system to the next, and lose extremely little optimization. In some cases, no optimization is lost at all. And we incorporate the next generation hardware and development as fast as MVAPIC itself does. So the cycle is about the same. So there is always an interface and connection between the underlying communication and the products. Okay, let me show you some xScale AI results. So this is inference using Llama 2. This is on cloud deployed, and there is a TPS difference between the baseline versus xScale AI. This was with the older NVIDIA T4. From inference, if we move on to scalable checkpoint restart. So this came out of the need for breaking up a very long path, a training path into chunks, which can be restarted later, and therefore you can free up resources. So we took a model which checkpoints only using root, and we changed it so that we can checkpoint locally across for every rank into local NVMe, and then we overlap the transfer of that data to storage with computations. So we reduced checkpointing overhead quite a bit at scale, and also as an added result, we have fault tolerance, because you can recreate the data if you have corruption on one of the ranks. And as a result, it's very well scalable across a number of GPUs, and the percentage of overhead is far less than if you have only root checkpointing, which introduces bottlenecks of failure. Another thing that we have done is hyperparameter optimization. So this work is done, so the previous work was on IB, and this one is done on Slingshot 11. We have leveraged the deep hyper HPO model, which incorporates quite a few HPO techniques. Here I show two different ones. There's more within deep hyper for massively parallel HPO. And we deploy it using ray clusters, which means you can create as many different workers as you want for as many different hyperparameters as you want. And then you can create a pool of workers, and then you can scale them up or down as much as you have freedom to or you want to. And then we containerize the system, which means you can deploy it wherever you want. So this is a result of tuning the learning rate on a very small parameter and a slightly larger parameter using two different HPO technique, and they both converge to about the same thing. And because it's scalable, you can up to some caveat, you can scale as many hyperparameters as you want, up to as many nodes or GPUs as you want. Okay, so then let me come to sorry. So this is available on AWS using that hyperlink. You can subscribe with a pay-as-you-go, or you can get a trial version. Okay, so next we offer a MVAPIC 2 tuned for BlueField DPU. Now, so this is a quick overview of the BlueField 3 DPU. It has up to 400 Gbps of InfiniBand. So this has a system on chip with a considerable amount of memory for each ARM core. And with that, what we can do is we can get it to support all features available with MVAPage 2s. And then we can offload all non-blocking collectives to DPU. I have some results showing all-to-all and blocking and also broadcast. Okay, so this is OSU all-to-all. This is done through the micro benchmark on Bluefield 2. So both are for a message size between 64K and 512K. One is 16 ppn and the other is 32 processes per node. But in both cases, you have significant reduction in execution time compared to bare and MVAPage 2. So this is for all-to-all with Bluefield 2. If you instead of doing bare, just pure all-to-all, if you go to an actual application, which this is PD3 DFFT, which uses quite a bit of all-to-all underneath. And the same results show we have significant 12% to 14% decrease, in some cases 21% decrease of total latency when you use MVAPage 2 tune for DPU. So we therefore claim a significant improvement and benefits in overall application level execution time. If we can, we also show this improvement if we go to point-to-point. So this is a point-to-point with a 3D stencil. We use GVMI to offload the send and or non-blocking send and receive to the DPU. And we show up to 18% benefit with the same 16 nodes, 32 ppn execution. This, and finally, this also carries over to point-to-point and reduction as well. And this is on Bluefield 3, where we show the compute plus communication total time reduction of more than 20%. This is on HPC, which I will show next in some more detail. So this is a mathematical solver, which in this case, it solves a 3D Laplacian. So we modified the solver algorithm to more efficiently offload reduction onto the DPU. And we can do this because we co-design something like HPC along with our MVAPage DPU. Now, that brings me to Xscale HPC, which is our HPC plus MVAPage co-design, an example of which you just saw. So HPC is a portable extensible toolkit for scientific computation. It has a large suite of linear solvers and nonlinear equation solvers and ODEs that powers a lot of applications that run on HPC clusters. It's used, for example, Amuse uses it, MFEM uses it. So one of the examples was if we offload it to DPU, we get about 24% reduction in total time. This is another example where we took the matrix vector multiplication kernel, which is a core linear solver multiplication kernel. And this is a stencil operation. And if we compare the bare HPC plus MVAPage 2 with our implementation, we get about a 13% improvement in performance, total performance. This was done on TAC Frontera. I think if you do it on a slightly newer system, you'll get even more improvement on it, which I haven't done. And you can see that it's almost scale agnostic. It's about the same on 4 nodes as 16 nodes. So these improvements should carry over as you scale it up. Here's another advantage, this time over Cray pitch on a slingshot network. So this was done with an AMD processor with 4 A100 accelerators. So this has a speed. So this is a weak scaling result, which means work per rank is relatively constant. So you can see that MVAPage, both MVAPage plus 4.1 and 5.0.0 scales pretty well, almost ideally, compared to Cray pitch. So this benefit comes essentially from the way MVAPage leverages pack-unpack, which is how you take broken up data and pack them together before scattering and gathering. And the second factor that gives you the optimization is that MVAPage Plus just has better dynamical tuning. So you don't have to tune for the right algorithm, it does it automatically. Okay, let me come to the next product, which is our specialized secure MPI. So this is a high-performance MPI library that has got built-in security and encryption. Now, why? Well, the previous speaker spoke quite beautifully in detail about why you need it. So our approach to this is that it has to be scalable and it has to be flexible enough for multiple cryptographic libraries. So we are compliant with TSL security management protocol. We support both point-to-point and collective operations, blocking and non-blocking. And its execution is, and installation and execution is no more complicated than doing it without the secured features. I will show some testing with micro benchmarks and applications both, and I go up to 1024 ranks to show how it scales. So this is a PD3, this is a DFFT, parallel FFT application kernel, which we use quite a bit. So so this is for 3 different problem sizes. And I compare an unsecured MPI versus a naive MPI secured versus our optimized MVAPIC secured. And the difference between, so the naive one is slower. It's a bit slower, 1.25 times slower. But the point that I will stress on is that the difference between a unsecured version and our optimized secure version is in some cases negligible. Depending on how much you need security, it won't affect you at all, your total time. And the last one is Xscale Monitor, which is a lightweight monitoring that we do as part of our work. So, but this is also now a standalone tool. This can be used for any HPC jobs and also for AI trading and inference. We have a database integration where you can back up your logs onto a database, and we ship it as a container for both Docker and Aptainer. So you can independently and immediately deploy them. We support quite a few high polling frequencies, less than 1 second without affecting the applications. Okay, so well, I think I have some time for questions, and I will be happy to engage with any end customers and collaborators. Do I have any time for questions?
Yeah, sure.
Okay.
Let's thank the speaker first.
Yeah. Let me thank DK's team because they provide the research that we from his students and his researchers and his developers who provide the research that we then act on and package it. Thank you so much.
Thank you. So do we have any questions for Soham? So I have one quick question. So you mentioned that you were using InfluxDB for your tool.
Right.
So I think in my previous conversations with attendees here, like particularly our gentlemen, they have mentioned that using, sorry, what was the name of the database again? ClickHouse is like significantly better. So do you have any thoughts of like pursuing that in terms of, so ClickHouse in previous evaluations did significantly better in terms of insertion and deletion. So do you have any plans of evaluating that?
Well, I actually don't know that, but I'll be happy to like look into that because or I'll talk to the developer of Xscale Monitor about it. So in what ways is it significantly better? Okay.
Would you mind using the mic, please? Thank you.
I think there's a few like clickhouse.com blog posts or something mentioning jump. We've moved a lot of stuff off of Influx DB to ClickHouse. So I think coming back from SC like 2 or 3 years ago, Ari and I had the same flight back, and he said, "Do you know any good databases?" And I told him about ClickHouse, and then they integrated that into INAM,
okay,
and had good success with it. So
okay, I'll be happy to take a look at that. Thank you so much.
Sure, thank you. Yes, Pippin.
And a quick question on the secure MPI. So how secure is it? Does it allow, or it doesn't allow people to track the traffic patterns so that you always have some noisy traffic? That means the distribution of messages is always random.
Well, so it's we don't rely on noise. We encrypt it before sending it off to the network.
Yeah, but when you encrypt it, I can still figure that you are doing something important. So just checking, that's another feature that could be. So for highly classified systems, that is very useful.
Yeah, I think that's a very nice suggestion. Always having like background traffic in going on so that it confuses any like snooping kind of attacks.
Yeah, you can't figure
Add it
out
with
whether someone
noise.
is communicating now or not, or who's communicating with whom.
Correct. I cannot reverse engineer saying, okay, hey, is it a tree-based communication? So maybe it's a reduction or an already use. So maybe I should be looking for gradients there. So yes, having random noise in the background can confuse that kind of reverse engineering type of attacks. A very good suggestion. Thank you. Any other questions for Soham? If not, let's thank the speaker.